The next method we're going to discuss for solving quadratic equations is completing the square. In order to complete the square, you're going to have to fiddle with this thing quite a bit. One of the best ways is to just go ahead and move that 6 over to the other side, or move your constant over to the other side. So I'm going to add 6 to both sides. Now, I look at this little thing and I think, okay, if he were to be something squared, he would need to be, and if you'll remember, and remember that I'm just reviewing, but if you'll remember, you take this middle term and you say, okay, he's always double. So half of 2 is 1. So this would need to be x minus 1 quantity squared. And multiplying this out, let's get a nice color yellow here. Alright, multiplying this little dealie out, it is x squared minus 2x plus 1. So I look at what I've got, which is sitting up here, and I say, what am I missing? Well, I'm missing a plus 1. So if I plus 1 to this side, I will need to plus 1 to the other side so that I have an equivalent relationship here. And this would then equal 7. Nice number there. At this point, you are in a perfect situation to do the square root property. So I'm going to take the square root of both sides, remembering my plus minus case. I'm going to take the square root of both sides, and what I'll have left is then x minus 1 equals plus minus square root of 7. I'll then add 1 to both sides, and x will equal 1 plus or minus the square root of 7. Very nice set of numbers there. It means I have two answers. I have the answer x plus the square root of 7 and 1 plus the square root of 7, and also the answer 1 minus the square root of 7. For my next example, I thought I'd do a really messy one that you wouldn't want to complete the square on, but it's really the only method that you can use. I would use the quadratic formula if I was to solve this, or I would try to factor it or something other than completing the square. But if you're working in the conic section, which means we're working with ellipses and circles, you have to use this method because I'm not interested in zeros. I have to complete the square in order to figure out how to draw my ellipse and my circle, figure out where the circle is, the center is, and the radius and whatnot. So what you'll do for this one is you need to get the coefficient off your x squared term, no matter what it is. Mine happens to be a 2, so I'll divide everything through by 2. So that will leave me with x squared plus 4x plus 3 halves equals, and then 0 divided by 2 is also 0. So that's fine there. Now it's exactly the same method that I did in the previous example. I'm going to scoot my 3 halves over to the other side by subtracting them. And I'll get x squared plus 4x equals negative 3 halves. Then I'll need to decide what quantity squared will get me this set of x's here. So you'll half the 4, and that will be x plus 2. Once again, I'll need to see what number should have been there, so I'll multiply this little dealie out. X squared plus 4x plus 4, and I see that I would need a plus 4, so I'm going to add 4 to both sides. Then, alright, so I've added 4 to both sides. The next thing I need to do is combine this little set of numbers. I'll need a common denominator, and that's 4 over 1, so my common denominator would be 2. So this 4 is actually 8 over 2. Combining that with negative 3 over 2 would give me 5 over 2. Then this is perfectly set up for the square root property, so I'll use that guy. I will take the square root of both sides, remembering my plus minus case. Next, I would end up with x plus 2 equals plus minus square root of 5 over 2. I'll subtract 2 from both sides, and I'll get negative 2 plus or minus the square root of 5 over the square root of 2. And I wrote it like that because because I know that I'll have to rationalize this denominator. Mathematicians hate square roots in the denominator, so I'm going to appease them at this point, make them happy, rationalize the denominator, and leave it in the proper form. So this would be negative 2 plus or minus square root of 5 times the square root of 2 is the square root of 10 all over the square root of 4, which would then be 2, and everyone is happy now.